All right, so here we are. Sorry for the delay. This is the third lecture. If you want to review the second lecture, it's posted on YouTube, and there's a link in MU Online that'll take you to the YouTube page where you can search by course number and lecture number. All of the videos are displayed in chronological order, and so you can find them that way. But if you want to search for something that's further in the past, you can do that as well. Your second homework assignment, the first one where you're actually doing some number crunching, that's available 48 hours from right now. It has to be uploaded to MU Online before class. So of course my suggestion is get in as early a start on that as possible. That way if you have any questions you can email me with enough time for me to respond to you. Okay, now another reminder, I'll always try and indicate what topic we're covering, and if you go back to the course schedule that I gave you on the first day of class, and which is also posted online, it shows you which book chapters correspond to the lecture items that we're doing. And I strongly encourage you to read along in the book with the material that we'll be discussing in class. It's, for most students, not enough to just hear something a single time in the lecture from one point of view to be able to really absorb and understand the material. In order for most people to learn and become masters of a certain topic, they have to hear it explained from a couple of different people on more than one occasion. And so if your goal is to get an A or a B in the class, then probably just listening to the lecture isn't going to be enough for you to understand that material. But if you read the textbook, then that'll get you a lot closer to fully understanding it. All right, so let's review cash flow diagrams. This is something that we talked about previously. And a typical cash flow diagram, remember that each one of these lines represents the end of a time period. And so what this illustration is meant to show is that the time period starts at the previous tick mark and goes to the next tick mark. And so from 0 to 1 is the first year. But the end of period assumption says that we kind of aggregate all of the revenue and all of the costs, and we express them at the end of the period. And so if you're operating a business and you have expenses that have to be paid out at the end of the time period, then you'd have a line down at the 1 to represent those costs. And likewise, if you had revenues, maybe they're in reality coming in all throughout a monthly period, but you sum them up and you express them at the end of the time period by putting them on the line 1. Now, here's a commonly made mistake. I didn't intend for it to be a trick question. I think it was on a quiz, but it turned out to be a trick question because I had provided a cash flow diagram to students, and I said, draw the inflows and the outflows. But the cash flow diagram had more years listed on it than you actually needed. So just because a cash flow diagram says maybe like 7, 8, 9, 10, that doesn't mean that the word problem is describing that same length of time. And so the duration of the graph that's available for you to sketch your information down on isn't necessarily going to line up with the word problem itself. It's just like the lines on a piece of paper. You don't always have to fill every line. As much as possible, you try and draw the line lengths to represent how much money there is. And I don't have a perfect hand by any stretch of the imagination, but proportion should give you an idea roughly of how much the amounts are. And just as a reminder for the course policies, please don't have your phone out during class. Please set that aside and stay focused on the material. Okay, so remember the labels that we talked about last time. P stands for an amount at time 0, so that's a present value. And 0 always means now, or it means the beginning point of a project. So if you're planning out a project that maybe is going to be constructed in the future, you set a time 0, and that may be when they break ground. It may be when the company begins to spend money. But 0 is assuming some present, which is the start, and then everything beyond that are future dates. All right, so I have an in-class exercise for you today. and it's got a front and a back on the paper. But for now, I'd like you to work only problems 1 and 2A. Although I realized after I wrote question 2, you need to at least know about part B says how much should you deposit today. So indicate the unknown amount on the cash flow diagram when you draw the cash flow diagram, even though you're not going to solve for it quite yet. The main point of the problem is eventually you're going to be solving for the amount, and we want to know how much. Remember, with these in-class exercises, you can definitely scoot next to a classmate. You can collaborate and talk. This is not quiet time. This is collaboration time when you're working on these in-class exercises. Okay, here's the cash flow diagram for that first problem if you want to compare. So remember, including labels, and today we reviewed the idea of P, which is a present amount, and F, which is a future amount. But from our previous class lecture, we had introduced the idea of an annual series. Does anybody remember what are some of the rules for something to be considered an annual series? There were a couple of restrictions or limitations we talked about on Thursday of last week. Okay, so the same amount, that's maybe the biggest of the rules. What else for it to be an annual series? Consecutive, right. So there can't be any gap years for it to be an annual series. It doesn't necessarily have to start at 1. It could have been 2, 3, 4, and that would be an annual series. But if it was 1, 2, 3, and then 5, 6, there would be 2 separate annual series there. It wouldn't be a single continuous annual series. So the rules are the amount has to be the same, and it's only an annual series as long as it's happening every period. Translating words into a cash flow diagram is a really important skill. And in the next couple of homework assignments, you're going to be doing it so much. In fact, sometimes it's a little bit tedious or challenging because it seems that until you get used to doing this, there's some ambiguity there. You kind of have to gain the experience to know what sort of assumptions are implied, and then it'll become a lot easier. Let me caution you again against accessing the author's solution manual online because, number 1, that's against the course policies. Number 2, it'll steal away a chance from you to actually learn the material and get stronger. And number 3, there's about 15% of the time the author's solution manual that's posted online, it's wrong. And it'll make some mistake, and if you copy that mistake, I'll know that you've copied it, and the penalties for inappropriate collaboration are pretty serious this semester. So please just do your own work, and if you have a question or a problem, please come see me in my office or send me an email. But my point is that translating from the word problem to the cash flow diagram, it's really useful because this summary that you can just glance at an instant and understand exactly what's going on, you can absorb the information more quickly in a visual way than you can with language. And so these cash flow diagrams are useful, and even on a problem where it doesn't explicitly tell you you have to draw the cash flow diagram, sometimes it will. Sometimes it'll tell you, you've got to do it. I'd suggest do it all the time just because it's worth summarizing in your mind what's going on. Where's the in, where's the out? It's a useful tool. All right, so any questions about this first one? Yes?
It says, what about the 85,000 for the 6th year?
Good point, for the 6th year. All right, so you'll notice that I've drawn, let me zoom in on it so it's maybe a little more clear. I've got these 1, 2, 3, 4, 5, 6 arrows. They're all a part of that annual series of 85,000. And then on top of that, I have a single future amount of 50,000. So another correct answer, there's not just one. Another correct answer would have been the annual series goes years 1 through 5, and then you've got a single future value what would that be, 135,000? All right, so that would also be full credit for that answer. For various reasons that we'll get into a lot later in the semester, I just prefer to keep the things separate because it was a separate payment. The 50 was from the salvage, the 85 was from revenue, but numerically, if you end up crunching the numbers and finding out how much is the value of all these future amounts, you'd get the same answer if you'd combined it. Thanks for asking about that. What was your question? Was it on question 2? Because I remember that was something I wanted to address. Okay, I remember what your issue was. All right, so on question 2, let's take a look at the cash flow diagram and the calculations for that one. So the cash flow diagram is pretty easy, but now remember somewhere on the cash flow diagram, if it says what the interest is, plop that on there. Above, below, to the side, just represent someplace that we're talking about an interest rate is 9%. So you want to receive 95,000. And the question I got was, so that 95,000 that you're getting, is that just the interest from how much you had deposited the first year? Or is it like a full liquidation of the account, meaning you're taking everything out that you got, including the interest and principal? And in this case, I guess you could have made, like in a test situation, if you calculated it's just the interest amount, then I would have been persuaded by that. I'd try and on an exam write a question so there's no ambiguity. But what I had intended is we're talking about you want to deposit the minimum amount in 0 that'll allow you to withdraw $95,000 in year 1. Because there's an infinite number of amounts that you could have deposited at year 0 and have the ability to take out $95,000 at 9%. It would be any number this or greater would enable you to do it. But what we're talking about is when you take out the money in year 1, you're taking it all out. So the key elements here for the cash flow diagram is that we have a downward arrow at 0 because that's you're depositing the money now so you can withdraw it in the future. So the line's up and the amount's 95,000. We're not sure how much it is. So that's why the question mark. And so the formula that I wrote up on the whiteboard before, the future amount is the present value times 1 plus I to the n. Forget about the n for now. We'll get to that later. In this case, there was just a single year, so n was 1. So you can find out, rearranging that, you can solve for the present value. And did everybody else get the same 87,155? All right. Very good. Were there other questions on problem 1 or problem 2 that we can go over before we get back into the lecture material? All right, so a couple of terminology things that we need to review. When we say economic equivalence, we're talking about the time value of money and the interest rate that's being charged or being paid as a fee for using money. Now, remember when we introduced the idea of time value of money, the word inflation was used. What's inflating when there's inflation? Inflation, I guess, maybe is a description of what's happening, but what's the thing that it's happening to? What's inflating?
Isn't it like prices like a different thing? Simply the value of money goes down?
Perfect. So he said prices. It's prices that are getting bigger. Sometimes people think, well, the value of money is getting bigger due to inflation, and it's actually the opposite. The value of money is getting smaller because there are more dollars in circulation, prices go up, and so inflation is inflating prices. Now, what we need to remember is that the inflation that occurs out in society, that's not always the same interest rate as the interest that you're making on your investments. Sometimes your investments will make more than inflation, and that's a really good thing. But unfortunately, sometimes you'll put your money into an account that's paying you back less than inflation. Like if you put your money into a checking account, it may earn 0 interest, and yet prices are always going higher and higher and higher. So reality, the money you put into that checking account, it's losing purchasing power with every passing day and every passing year. But what the economic equivalence says is that what we're going to try and do is take into account a single interest rate. And that single interest rate, later on, we'll talk about how you choose the interest rate that you're going to use for determining economic equivalence. It's kind of a combination of things. It's a combination of inflation. It's a combination of the rate of return your company may want to earn. But the economic equivalence is saying that if you make a cash flow diagram for some certain interest rate I and for a time t, then all of the money in the future is balanced out by money at the present. So here's a cash flow diagram that just summarizes the concept. It says that if you make a deposit of $100 now and the interest rate that we have of interest is 10% per year, then in 1 year that $100 has an economic equivalence value of 110. So that's how much you could withdraw if you had put it into an account that paid 10% per year. Any questions so far? So just in words, that's saying the same thing that we can see from the cash flow diagram. 100 now is equivalent to 110 1 year from now if the 100 is invested at 10% per year. Now, one thing that you have to be sensitive to, though, is that a deposit and a withdrawal aren't the same thing. It's just the amounts that are the same here. So we're saying that the magnitude of the economic equivalence is equal between 0 and 1, but the note that I've added here, a deposit is not equivalent to a withdrawal. So sometimes when we're doing problems, we'll get into these cash flow diagram problems, and I'll tell you, move the money from year 1 to year 0. And so if it's an inflow, it'll stay an inflow when you discount that money to the present, or when you compound it to the future. When you're moving money around in the cash flow diagram, it should have the same direction. That's the rule. But the illustration here is more about if you made a deposit, then you would be able to make a withdrawal. And so that's why they flipped the sign. It's context specific. You have to kind of read the word problem and see, all right, so are we talking about a bank account here, or are we talking about a business opportunity? And you kind of have to be sensitive to the context to know whether or not to flip the direction of the cash flow diagram. It won't be a huge issue. I think it'll come naturally to you. But I just wanted to point out, since we're talking about equivalence, that it's the amounts that are equivalent because of the time value of money. It's not that a deposit and a withdrawal are the same.
So like if you deposit $100 and you're on some plan to where it will remain $100 depending on what the value of the dollar is at that time, will that change respectfully? Like if the value goes down, would that drop down to below 100?
So you're saying if you're on a plan,
Well,
you mean like if you want your purchasing power to stay the same?
Well, yeah, like, the amount's not equal, so you gain the $10 because that's equal to what $100 was a year ago.
Okay.
Will that change respectfully? Like
Okay. So yeah, the number is the same. So what's equivalent about it? If inflation was 10% per year, then what would be equivalent about this is you could buy the same amount of stuff. In year 0, when you had $100, you could buy $100 worth of groceries. If you put it into this 10% account, what you're preserving by making that investment is you're preserving your purchasing power. And so there are a handful of accounts out there where the interest amount that you're earning either increases or decreases with inflation. There's the U.S. government sells a treasury product called TIPS, TIPS, and the amount you earn goes up and down depending on inflation. You're kind of protected. Most investments, though, don't float up and down with inflation. Most of the time, just the bank pays you what they say they're going to pay you, and it may go up and down, and you always have to make sure that you're earning a good rate of return. All right, so here is some cash flow diagrams where we need to go over what the diagram is asking and how to express that in a notation. So just to begin with, this problem statement, what we say is you're given a present amount, that's known, and the dashed line and these question marks tell us that the future amount is unknown. And so the way that we're going to describe this problem, this is a find f given p. And so well, the way to summarize that is f slash p. We wouldn't say, for reasons you'll see in a little bit, we wouldn't say p slash f. It's not given p find f. The way we write it is always going to be find f given p. And the reason why we have the unknown up in the numerator of a fraction is that the equations we're going to use are based on being able to move the denominator over to the right-hand side of the equation and solve for the unknown. So that's why this whole thing is structured to have the unknown first and the known second when we give it this verbal summary, find f given p. Okay, so if this first one was find f given p, what is this? Find p given f, or in terms of like the this bottom one, it would be p slash f. Okay, so p slash f. So p slash f means find p given f. So if you have a problem like this, a cash flow diagram that looks like that, you could go to the equation table. I'm going to give you an equation table, and it's the same equation table that you'll actually be able to use on the FE exam. It has formulas for how to solve for some unknown p given f. And it has formulas for a lot of different situations that become increasingly kind of complex. Okay, what about this one? How would you describe this? Find what given what?
Find the annual income given the principal.
Right, good. So find A given P, or A slash P, and of course the last one, this would be find P given A. So the unknown comes first, and we are expressing the unknown with some sort of a dashed line and question marks, and then the known amount is defined and has a solid line. Okay, so this will be our kind of sign convention and our summary convention. Any questions about this standard approach that we're going to use? We've only spent maybe 1 or 2 minutes on this slide, but it is really important that you follow this approach in order to be able to use the right equation in finding the answers. And there will be tables where you'll look up on tables a certain column to find a solution, because sometimes you'll use the formula for solving these problems, and sometimes in the back of the book there are these interest rate tables where they've actually solved the formula for you, and you're just going to apply a factor to solve it. And so you'll need to know which column to look in, and which column to look in, it'll say at the top of the column f slash p, p slash f, a slash p, and you'll have to know which column to use in order to get the question right. All right, so maybe put a star in your slides for this one and come back to it later to refresh your memory and reinforce that idea. All right, so for the rest of our class time, we're going to be looking at problem 3 on the in-class exercise paper, and then on the back side is one where we're talking about the effect of compound interest. Now, I don't want to talk too much about problem 4 because I want to see if you can figure it out first. As you work through it, I'll be circulating around the classroom with the answer if you want to check and make sure you're on the right track. And of course, I'll put the solution up on the screen before we finish class so that you can make sure that you had the right idea with problem 4. But you can think of problem 4 as we're doing just one time, we're solving this the hard way, and then I'm going to show you a lot of different ways to solve this type of problem the easy way. Part 3B, it's a 20% total return. It's not annual return of 20%. Just to emphasize that it's a total return. Okay, so on problem 4, you're doing an annual equivalence question. And what you're trying to do is you're trying to move the money from year 0 all the way to year 4. You're moving this money in year 1 to year 4. You're moving the amount from year 2 to year 4. And the first approach that I've suggested you take for this one is you find out, okay, this $12,500 that's in year 0, if you have it increase by 5%, how much is the total amount now that's in year 1 when you've moved it? So what you got to think of, I'm moving this arrow from 0 to 1. And so you're going to stack them on top of each other in year 1. But when you move the amount from 0 to 1, it's no longer 12,500. It's going to be 12,500 times 1.05. So you're adding the 1.05 times 12,500, so that whatever that amount is, to the amount that is in year 1, which is 12,500. So now you've got a bigger arrow. And then you're moving that arrow from year 1 to year 2. And so anytime you move an arrow, you're going to have to multiply the cumulative amount by 1.05 to account for the time value of money. And eventually you'll get all those arrows to 4, and you won't have to compound anymore. You'll find the total cumulative amount. So I'll circulate around with the solution if you want to double check if you're on the right track, and then I'll bring the overall answer up on the screen in just a few minutes. Just this one time that I want us to do things kind of the slow, uncomfortable way. There will definitely be faster ways to do it in the future, but at least now you've seen the effects of compound interest manually calculated this one time. Let me pull up the solution first of all to the aviation fuel problem. All right, so the main question is which of the two options is better? Buy now or buy in the future? And the conceit of this problem, the premise is just like you're going to spend $260,000 now regardless of what you do. If you have to buy the fuel and store it, you're going to pay $260,000, or you can take that same money and put it in the bank. But the proof that option B is better is that you'll be able to buy the fuel you need and still have money left over. So you buy the required fuel and you have $47,000 remaining. All right. Any questions about that? I'm just noticing that my scan doesn't appear to have picked up the back side of the paper. So let me use Cam Scanner for that one. You give me. Okay, so let's go over the solution for problem 4 and then we can be finished for today. We've got a cash flow diagram where we are going to receive payments starting in year 0, starting at the present, and then 1 year from now, 2 years from now, 3 years from now, 12,500 AED. That's United Arab Emirates dirhams. That's the currency of the UAE. So the question is, how much do we have to pay back if we had this annual series of payments? And so here's the solution that I followed. What I'm always trying to do is keep track of when the money is, not just the amounts. Like if you only wrote the amounts and you didn't write down the when, it's really easy to get confused and to forget when the money is in addition to how much it is. So you'll see from 0 to 1. What I mean by 0 to 1 is I'm moving the amount that was in year 0, moving it to year 1 by compounding it. That's what it's called when you move money into the future and the amount increases. We call that compounding it. So what used to be $12,000 in year 0, the economic equivalent amount in year 1, when we have 5% annual interest, is $13,125. So now what's the total amount at year 1? So at year 1, it's the $13,125, the $12,500, so $25,625 is at year 1. Now I know lots of you already have these amounts, so don't tune out just because you have the amount. I think maybe even more important than getting the correct amounts is thinking about, try to visualize that arrow as the arrow is moving in the cash flow diagram from 0 to 1. And so think about how is the cash flow diagram changing, and how do those arrows stack on top of each other as you do the calculations. And so now we've got some money at year 1 and then also the future amounts as well. So what we're doing with this 1 to 2 arrow is we're saying let's compound the total that was at year 1 year into the future and make it so that it's in year 2. But then we know that there already was another $12,500 already at year 2. And so the total amount at year 2 becomes this $39,406. And then we move that from 2 to 3 by compounding at 5% interest. It becomes $41,376. But there already was a single amount at year 3. That was the $12,500 that was at year 3. So now we've got all of the inflows as a single amount at year 3. And that single amount at year 3 is $53,876, but we have to move it one more year to year 4. So now, once we get to year 4, we're not adding the $12,500 again because that isn't in year 4. But it's the payment that we were looking for, the payment amount. So any questions about question 4? Anything you want to ask about? Okay, so before we break a couple of minutes early, let's just take one last look at these announcements. The homework assignment that you've got, that's due Thursday, has to be uploaded before 8 a.m. My suggestion is while this stuff is still fresh in your mind, do that homework as soon as possible. You'll spend either 50 minutes now or 75 minutes if you're doing it Wednesday night at midnight and kind of don't remember as well. So get an early start and it'll be to your benefit. All right, have a good day. I'll see you on Thursday.